Great. So it was really nice session on the data from the Mohammed, and we have another session on the abstractions using APIs by the Vikram. So yeah, Vikram is here. Hey
Hi, Trey.
Vikram, welcome to the API days.
Thanks for having me here.
Yeah, please share your learnings with the abstraction in APIs, and we are interested. Yeah.
Sure. Hello, folks. Good morning, good evening, wherever you are. This is Vikram Vasudevan, founder of Ekahaa Solutions, and we specialize in data abstraction solutions. So I'm going to, talk more about what we do and how, and based on our learnings over the years. Typically, when it comes to API, there has always been a lot of focus on API management, monetization, performance monitoring, caching, things like that. But very seldom people talk about a very, very key, possibly underrated aspect of APIs. And in my view, it is the abstraction, right? The API building, right? That is where really things happen. When you build the APIs, you connect to various different types of data sources. And there's a lot of complexity in that, which I'm going to be touching upon in my presentation today. So essentially, abstraction, if you look up Wikipedia, and all of us know what abstraction is, generally, in a very general sense, it means hiding the complexities of the underlying subsystem, right? It's no different in the API world. So in case of APIs, though, there is many different levels of abstraction. And today, the agenda would be to talk in general about what abstraction is and the key principles. I'll be touching upon the very interesting topic on what would be my ideal API-driven data abstraction platform, right? And then we'll have a bit of Q&A if time permits. So what is abstraction? In computing terms, as we know, abstraction is a way of hiding the working details of a subsystem. When you see a restaurant, for example, you see all the nice ambience, and you see the good environment around you, and you want to eat there, but then you don't realize how complex it was to build that, or not build, cook that food, basically, right? If you go into the kitchen, you see how complex that whole back end is, right? So in a way, restaurant abstracts the kitchen itself, which by itself is a very complex system inside. In a database context, we as technical people, you guys might have created views or procedures, functions, and whatnot, which kind of abstracts the complexity of the underlying data model. And for somebody who's using the view, they don't really see what it takes to build that view. So that in itself is a big abstraction at a database level. And in an API context, in my view, API itself is a big abstraction. What you see as a beautiful web application that you have access to, what it actually is vast different, isn't it? You have a big infrastructure behind it. You have the client-server architecture. You have the microservices. You have the gateways. You have the CDNs and whatnot. You have the API management solutions. Load balancers, and so on and so forth. So it's a highly complex system, but what you access as an API, that itself is an abstraction. So abstraction, in my view, it's not limited to certain segments or certain areas, right? It's all over, isn't it? So you have everywhere you can actually see how abstraction works, right? So that's one interesting thing I wanted to bring up. Now, and recently after the advent of the cloud, you might have seen infrastructure as cloud tools. That is again another form of abstraction. When you ask for deploying an application to my GCP cloud, for instance, what happens underneath is it spawns your cloud computing system, it creates your databases, it sets up your networking, the VPNs, the VPCs, the storage, the virtual machines and whatnot, the compute. It sets up everything behind the scenes, and as a user, you don't realize what just the deploying command does. That's what infrastructure as code tools does. They abstract the complexities of the underlying cloud architectures. So when you talk about, we can keep talking about more and more of these use cases. Earlier in the day, people were talking about open banking use cases. There are abstraction happening at that level. There is abstraction happening in the logistics world, where the PLCs get abstracted. You can talk to various different PLCs. The general idea is you are in a system where you don't want to keep repeating yourself. There's a concept called dry, right? Don't repeat yourself. So you have this is one of the key principles of abstraction, right? You have of course you're building a very complex system, but you still have to make sure you do it in a very efficient way, in an optimized way, right? So one of the key principles of abstraction is not to repeat ourselves and having redundancies, not having redundancies or not having repetitions of software patterns. Redundancies are okay as far as performance enhancements go, but in a general sense, don't repeat your code everywhere. Over maintenance and technical debt actually builds up for you. There's a concept of wet, where you say write everything twice, only if that is the best way to solve your problem, right? And generally speaking, the abstraction is not the only way to achieve something. Sometimes not doing abstraction is also better. Depends on a case-to-case basis. That's where you have the AHA, the avoid hasty abstractions. And then obviously the key principle of abstraction is to mask the underlying complexity of anything, right? So don't let your users know what the complexities are. Try to keep it simple for them, right? I found these dry, wet, and AHA very funny. The people come up with interesting jargons, and these I found them very funny. So I just thought I'll present it here. In the case of data sources, right, this is where I want to focus the remaining part of this discussion on, right? Imagine being in a conference like this, where we are interfacing with so many different people coming from various different cultures, diverse backgrounds, everybody having their own, language, semantics, and everything. Imagine me as a speaker coming into this conference, being able to have an effective conversation with every single one of you, despite not knowing your cultures, your backgrounds, your languages. How will that look? So that analogy, if you apply it to the data sources, right? In today's world, there are so many different types of data sources. You have the SQL data sources, the legacy ones. You have the NoSQL data sources, the graph DBs, the influx time series databases. You have various ERPs. You have incident processing systems, ticketing systems like ServiceNow, Jira, and whatnot. You have APIs themselves behaving as data sources many times. You have the Python, you have JavaScripts. So many different types of data sources. In fact, I have hardly even covered probably 20-25% of the entire superset of the data source. So in that sense, having a system that can effectively talk to all of these data sources without understanding the underlying semantics, talking in a unified language would be a big challenge, isn't it? So that is one of the key challenges when it comes to data source abstraction, and I believe at the API level there is a huge scope to abstract that complexity, right? And typically this is a topic that many wouldn't actually take up separately, and you might have hardly seen this topic discussed separately like this. The reason being, every tool or every product there is actually implicitly addresses this need, because this need has always been there, isn't it? You build a product, you normally have to talk to so many different types of data sources. So the need to interface with data sources has always been there. And how the products solve this challenge is pretty much left to the product. There isn't a very singular focus on this problem per se. That's probably why you haven't heard this as much as it should have been. Essentially, it boils down to four pillars, right? Four aspects of data source abstraction, right? The way I look at it, right? You need to unify your data, right? You have so many different types of data sources. You need to bring them all about to your platform, right? You have to unify them. Then you need to fortify them, meaning we have to build a governance layer around your data sources so that you don't have silos operating that do not talk to each other, right? You restify them, right? So that you provide a singular language through which you can talk to all of your different types of data sources, right? And then you allow your data to be democratized, right? That's the eventual thing about data, is that it doesn't sit in one place, right? It doesn't have any value sitting in one place. So data propagates. So you have to democratize your data eventually. So just to summarize the four pillars, right? You build a unified layer of disparate data sources that provides you a singular language or a singular data access point through which all of your data sources can be governed, right? You fortify them using policies, security policies at various levels. Again, there is generally, when you talk about APIs, you normally talk about who can access what APIs, but you shouldn't be stopping at that, should you, right? You probably have to have control at a row level, at a field level. If you're talking about NoSQL, you need to have control at your document or attribute levels, right? And then you provide a very powerful REST interface that can be equally that has the flexibility of a GraphQL, at the same time very powerful and very natural in the form of a REST. Providing CRUD operations on your data sources is a very good thing, because again, all this thing packaged together in a no-code platform. Imagine how it would be for the domain users when they do not have to code to do all these things and be instantly be close to their data and have access to the data, and yet do it in a secure way. Right, so that is the key aspect of these four pillars. Eventually, like I said, once you do all this, propagation of data has to take prominence. You need to make sure that your data is able to be propagated through various mechanisms, such as event-driven paradigms or schedule-driven, or based on an ad hoc request. You have to give various channels to your consumers of your data, and making it very effective for them to access their data, at the same time do so in a secure manner. The API building itself is a very complex affair. I just wanted to highlight what goes behind a single API itself, right? And all of us are aware of it, but then when you put down in the form of a picture like this, it kind of it kind of reiterates how complex this API can be, right? You identify a data source, that's where it all starts. Then you set up the infrastructure, right? And then you write lots of code to define the API, right? And then you add security policies. You need to have documentation support, right? And then you need to have versioning for your APIs. And then your users have to be able to test your APIs through tools such as Postman, and then eventually you deploy the APIs. Imagine a no-code platform that kind of takes care of all these complexities, allowing you to focus more on your business, right? So that should be the ideal goal for anybody. So if you look at an engineer's day, traditionally you have seen engineers toil day in and day out coding, testing, DevOps, and security. They spent a lot on these four activities, but their time allocated to generate business value is far less ideal, right? When you implement a data abstraction platform, right, it's going to make your engineers spend more time generating business value, right, and then allowing them to focus more on your business rather than those repetitive activities on coding, testing, DevOps, security. So in summary, an API-driven data abstraction platform, right? What is my view of an API-driven data abstraction platform? Here it is, right? So it needs to support API building, right? That means it's not just about defining APIs or just documenting APIs. It's also about building. As that's actually the first step that happens in an API, isn't it? You have to build your APIs by connecting to various data sources and write your business logic in there, right? So the API building on the fly is a very key ingredient of a API driven data abstraction platform. It has to be able to connect to major data sources that are in use today. At the same time, it has to keep up to newer and newer data sources that keep getting spawned up day in day out. So we have to keep up to date on the developments in the data world, right? And then that means that it's not sometimes possible as a product to just add connectors left and right as and when data sources come. So that is where the community driven connector model comes in very handy, isn't it? So that is, to me, is a very, very key component. Auto discovery of resources is a very, very good thing to have, in the sense that when you, especially in a relational sense, when the entities, the relationships are defined clearly in your metadata, all your platform has to do is to browse the metadata, understand the entities and relationships, and auto discover all your resources on the fly, right? That will add a lot of benefit in terms of time to market, especially if you're going to convert all your data into APIs. This kind of functionality can add a lot of value. Customization, obviously, when there are going to be advanced users who want to create their own business logic, something that is not supported out of the box in your platform, so you need to allow for customization. And very important aspect is to have versioning support, right? So whenever you make changes, you need to make sure that versions keep getting created, there is backwards compatibility, and existing API consumers don't have a negative impact, and so on and so forth. This is on the API building front, right? And then there is a very interesting thing in the API security, right? There is always going to be SSL support. You're dealing with data, folks, right? So obviously, the bare minimum that you have to do is go for SSL support. And on top of it, there are going to be classified data sources for which you have to support payload encryption, right? Especially in the financial world. You don't want to expose things like, for example, social security numbers or bank account numbers or credit card numbers, whatever. So you need to encrypt the payload itself. That will add additional security on top of the SSL encryption, right? And the other thing is about the multi-tiered security model, right? You need to have policy-driven access control at API level. So I should be able to say Vikram can access this API. That's not just that. Vikram can access this specific data records only based on a business rule, right? And if you want to go further and say Vikram can access these specific attributes in these specific data records, so that level of security should be possible without writing any code. Obviously, API management has got to be done, right? Because eventually, without that, your APIs can get scattered all over, and it's going to be complex managing without a management platform. So you go for various API management solutions, or you can build one as part of your product itself. Have that has a gateway, that has monetization capabilities, performance monitoring, load balancing, and all that good stuff. And one key aspect is on the data management side, where if you allow out of the box CRUD capabilities for all these data sources. A very classic example would be, for example, you have a transaction database where transactions keep flowing in, and then you want to monitor those transactions. Let's say there is an anti-money laundering team sitting in one place trying to monitor these transactions, and they want to red flag certain transactions based on some business rules, right? So these kind of things can be done when you have your own event management capabilities. You have CRUD capabilities where you enter a transaction, and based on some business rules, you are able to load data into a ServiceNow system and create an incident, right? So that kind of an integration is what will be very useful for business users. You need to have data governance capabilities. You need to have auditing, which is readily reportable for compliance purposes. You need to know who did what type of changes, etc. There is so much of data democratization support. You need to have the transformational support, the event-driven propagation, support for OLTP and OLAP, access patterns. So essentially, this kind of shows a summary of what an API-driven data abstraction platform should ideally contain, right? This kind of gives you a feeling of what if you were to build one, what are all the components that you would need to have. And if you look at this picture, it's just a different way of representing whatever I had iterated just a while back. You can look at different personas, right? This kind of system will come in very handy for developers in some ways, for testers in some other ways, for administration in many ways, and security aspects as well. So what would you get out of it is basically your API releases can be faster. You'll become more agile, right? And development testing times come down, and you can reach to your customers faster than you have. Your TCO comes down drastically, because you don't have a repetition. Like I said earlier, you eliminate redundancies, and you have massive savings in development and infra costs. Now, operationally, you become very efficient, right? Because you have everything in a singular platform, managing all of your different types of data sources, making it so easy for your end users to navigate through your data. So with that, I'll probably pass for Q&A. If there are any questions, I can take up now.
Hey Vikram, thank you very much for sharing about the abstraction of APIs and how somebody can implement. So we do have a very good question from the audience on how, as an organization, they can consider about the abstraction of APIs, like when they are a small team and when they are trying to grow. So like how they should initiate across the org and across the team. Your thoughts on
Right.
this?
Yeah. So when you look at abstraction, right, preferably it's something that you have to start putting your thoughts on right at the beginning, because when you're starting lean, and you don't have that many data sources to begin with. So when you do that, at that time, if you build the abstraction layer and keep maintaining it over time, then you become more and more efficient. And after a few years go by, you turn back, you're looking at 50 different data sources in your org, and you're able to effectively still govern all your data sources, versus not having an abstraction initially, and then you let your data sources grow and grow and grow, and one fine day it's all scattered all over, and there are so many silos, and not the silos don't interact with each other, and you don't have any standardized way of communicating between them. So in that sense, building the abstraction layer should be your first priority when you begin. But in the case where you don't have one, it's never too late, isn't it? You still have to start thinking right now and start building towards a good abstraction layer, is my opinion.
Okay, perfect. Thank you, Vikram, for sharing your learnings and talk.